Hello everyone and welcome back to another episode. In this part, we'll continue the adventure into function hooking via DLL hijack. We've discussed in the previous part a hooking technique via app-init-DLL's registry key. We've injected a DLL into an application and seen how to hijack specific functions. Initially, we simply hijacked the message box API, then moved on to another application. We wrote a basic random number generator in C. Why would someone try to hijack a random number generator? There are many possible scenarios. For example, in cryptographic-related algorithms. If we would manage to control the random number generator, the output of the whole algorithm would still seem realistic enough to pass any randomness tests. A trick like this would open a very difficult to detect backdoor hidden into a low-level function. Our example here is basic. We call the rand function from a standard library. If we want to hijack rand function, we need to first figure out where it is defined, same as we've done in the previous example. We need to figure out in which library is defined, and after that, replace it with our own version. We'll use CFF Explorer and later IDA Pro to have a look at the file. You can probably guess at this point what we plan to investigate in CFF Explorer, but let's see. Looking at the import section, notice that it only imports the kernel32.dll library. Let's check the imported functions too. There is no rand function here. This is strange. Let's open the file in IDA Pro and see what's happening. Drag and drop the binary into IDA, a 64-bit binary, loaded, OK. Let's search for the main function. There is no function called main here, but don't worry, that's not a problem. We can simply search for the strings we've defined in the code and they will lead us to the main function. In the strings window, we can filter for any text. Let's see what messages we have in the code. I'll just take some text and search for it. From the string, we can check cross-references and quickly reach the main function. Rename it for convenience and let's continue the analysis. The function uses the string in this block over here, which is very probably the printf function. OK, this is printf. What is it going to print? The result of the function above. Let's see what that is. This has to be the random number generator function. Let's rename it and study it a bit. It's very interesting what happened here. You might see this technique. Although we used the rand function, the compiler decided to optimize the code a bit for us. That's why we couldn't find any imported function called rand when we checked the import section in CFF Explorer. Nice trick to keep in mind. The compiler replaced the rand function with this code over here, which looks interesting. If you're not convinced that this generates random numbers, you can look up these two constants online. You would discover that they are used in a linear random number generator algorithm. Great so far. Okay, so we understand what happened here, but we still want to somehow hijack the random number generator and more precisely the rand function. The function is probably very common and the compiler created a very efficient inline version of it. Alright, we cannot use the previous approach since there is no function to hijack. What should we do? Actually, in production-grade code, we would probably not see the rand function. We would see a cryptographically secure random number generator. I have an example over here. Let's look at the code and understand the differences. It uses a library function called crypt_gen_random. The code has exactly the same functionality. Just that in this case it will acquire a cryptographic context first, then generate cryptographically secure random numbers. This is a lot more secure. Let's compile the code. Our goal is now hijacking the function above, crypt_gen_random. This is v2 version 2. The command line is almost the same. The CL compiler binary will trigger a few pop-ups. If you remember from the previous parts, they come from app-init.dll's library hijack. So we got the version 2, myrand v2. Let's run that from the desktop too. The program works fine, but we don't see any message box to signal that also the library injection worked. Why? Pause the video here and take time to figure out why. Okay, got it? Okay, I assume you did the research online and came up with a good explanation. The DLLs we specify in the app-init.dll's registry key are only injected in applications that link with user32 Windows library, most but not all applications. In this case, we have a simple console application, for which there was no need to link against user32.dll library. To make sure, we can check its imports. We have only kernel32 and ADV API32 advanced APIs, which is used for importing the crypto functions. So let's manually link against the user32 library and recompile. Got version 2 here. What can we see in CFF Explorer? The program doesn't import the library. More mysteries. Not only that, but there's still no DLL injection. Clearly our plan didn't work as expected. The compiler is smart and it didn't link with user32 because we didn't use any function from that library. Simply call a function from user32 like messagebox that we've used before and recompile the code. Let's check the imports. Now we see user32 and from user32 library we import the messagebox function. Great! If we rerun the binary, the hooking DLL will be injected. We learned another useful piece of information. App-init DLLs are only injected into applications that link with user32. In this part, we've also seen how to create a more serious application that uses a a graphically secure random number generator. In the next part, we'll continue from here and see how to hook the cryptGenerRandom function and generate our own numbers. Thank you very much for watching. Let me know any comments and suggestions in the notes and see you in the next episode. Cheers!